Okay, so let's talk about domain and range. So domain is going to be all your x values, all right, all the x values. And range is going to be your y's. So let's take a look at this example very quickly. I'm going to draw a line right here. So let's just say right here, that. So you got -1, -2, -3, -4, -5. 1, 2, 3, 4, 5, 6. All right, something like this. And then I'm going to have this line that goes from right here all the way to, let's just say, right here. Something like this. If you take a look at this line, the line starts right here. This is where it starts. So you read a graph from left to right. Just like how you read English, you read it from left to right. So that means it starts right here. And then it will keep going up and to the right, and it will end right here. All right, so it starts down here and then it ends up here. So when we talk about domain and range, domain is all your x values. So all your x value means you have to check how far left and right does your graph goes. All right, how far left and how far right does it go? And we only care about how far left and right. We don't care about how high and how low. So if you look at this line, the furthest left is where it starts. It starts right here. This is the furthest left. So this is probably around -3. So that means your domain, it will start at -3. And this is a closed circle. So closed circle means it is included. It is part of it, all right? It is part of it. So that means I will use a bracket. I will use a bracket. And then the furthest right is right here. This is as far right as it goes. So this is where it stops. And this is somewhere around 6, right? +6. And this is an open circle. Open circle means +6 is not included. It is not part of the line. So we will use a parenthesis. So it starts at -3. It goes all the way to +6. -3 is not is included because we have a closed circle, so we'll use a bracket. And then +6 is not included because of the open circle. We will use a parenthesis. All right, so this is interval notation. So now let's take a look at the problems right here. So find the domain and range of each graph and then solve for the intercept algebraically. Alright, so how about we go with the easy one? So let's look at this one right here. So this line, it starts from the left. And if you see this arrow right here, that means the line, it will keep going on and on and on forever to the upper left. Alright, it will never stop. So I need you to use your imagination. Use your imagination and try to pretend that the line, it will keep going on and on and on to the upper left forever. And then the same for the right side, all right? It will just keep going on and on and on forever to the right. So this absolute value graph right here, it starts at negative infinity. Since this line right here, it will keep going to the left and it will keep going higher and higher forever. So that means it starts at negative infinity. And then the right side will be positive infinity because it will never stop. All right, it never stops. It will just keep going further and further right, higher and higher. So this means the furthest left is negative infinity. And then the furthest right is positive infinity. And for infinity, you always use a parenthesis like this. All right, now let's look at the range. So range is how high and how low the line goes. How high and how low this graph goes. All right, now we are not looking at how far left and right. We don't care about how far left or how far right. We only look at the highest point and the lowest point. So the lowest point for this one is going to be right here. This is as low as it gets, all right, the lowest point. And if you don't see a open circle, we will assume this is a closed circle. That means the lowest point right here is included, all right, it is part of the function. So this is negative 1. And since it is included, we will use a bracket. And then how high does it go? So both the left and the right will always keep going higher and higher and higher, and it will never stop. So if they keep going higher and higher and never stops, that means it will approach infinity, and we will use a parenthesis right here. And then the last thing you have to do is solve for the y-intercept. So y-intercept is where it crosses the y-axis. Where it crosses the y-axis. So that means it is going to be right here. So if you look at the graph, you can kind of tell, you can tell exactly where the y-intercept is right here. And this is going to be 0 and 4. So the location of the y-intercept is 0 and 4. Since they are asking you to solve it algebraically, so that means you have to look at the equations right here. So let's see how we're going to solve this. So g of x equals to absolute value of x minus 5 and then minus 1. So g of x is just a really fancy way of saying y. So for now, let's just put it back as y. And then what happened at the y-intercept right here? What happened at the y-intercept? On the y-intercept, the x value is 0. All right, the x value is 0. So x value, you look at the x-axis right here. You got 0, you got 1, 2, 3, 4, and so on. So when the line crosses the y-axis, you are looking at the x value as 0. So that means you have to put x as 0. So basically what you are trying to do is you are trying to ask what is the y value when x equals to 0. So you are trying to find out what is the y value, which is right here. What is the y value when x equals to 0? That is what you're trying to do. So now let's solve it. So if you want to solve for y, you have to first get rid of the minus 1 right here. This is what you have to do first. So that means plus 1 on both sides. And then 0 minus 5 is just negative 5. And then absolute value of negative 5 is positive 5. And then now solve for y, that means minus 1 on both sides. So y equals to 4. Y equals to 4. So the y-intercept, you always have the x value of 0. You don't even have to calculate it. It's always going to be 0. The x values will always be 0. And then the y values, you just calculate it right here. So that means you are looking at 4. So the location of y-intercept is 0 and 4. Alright, the next one, quadratic. So this quadratic function, and you have to find the domain and range. So domain, once again, is how far left and how far right does it go. So you will have to use your imagination, alright? Use your imagination. It keeps going up and up, and it will keep going further and further left. And then same for this one right here. It will just keep going higher and higher and higher, and it will keep going to the right. So that means the furthest left is negative infinity, and then the furthest right is positive infinity. And then for the range, it's going to be how high and how low does it go, right? How high and how low. Alright, this line right here is tricky because this thing is slightly off to the left. Wow, you can't even look at the graph. Okay, yeah, this is tricky because if you look at it, the whole thing is slightly to the left. It moves shift to the left for just a little bit. So that means it's going to be right here. This is the line of symmetry. It's a little bit off the y-axis. This is really tricky. Alright, so that means you're probably going to have to solve it algebraically. You have to do it, solve the equation. So let's see. All right, so the lowest point of this line is going to be right here, a little bit off. And it will be exactly at the line of symmetry, which is right here. So the line of symmetry is what split the graphs in half, all right? You have the left half and then you have the right half. So you can use the, let me see, line of symmetry. You can use this to help you find it. All right, so the A is 2, and then B is 1. Now put it back into this formula right here. So that means -1 divided by 2 times 2. That means -1/4. So the line is symmetrical at x equals to -1/4. -1/4, that's probably somewhere around here. So at -1/4, that is when you have the line of symmetry. And then the vertex, the tip, is located right here. So that means now you have to find the y value when x is -1/4. So plug in the -1/4. Oh, it's going to be a nasty number. So that means the lowest point is -15.125. And then the highest point is infinity. And then this is included because there's no open circle. If there is no open circle, we will assume that it is a closed circle. And then it will go as high as infinity. And then y-intercept. Y-intercept is when the line crosses the y-axis. And when it crosses the y-axis, you are looking at the x value being 0. Alright, so x value is 0. So just like before, we are going to plug in a 0. So you are looking at the y-intercept at 0 right here, and then negative 15. And then the other two right here. Alright, I'm not going to do it for you, but I want you to give it a try, alright? Give it a try. So that means the furthest left is right here. This is as far left as it goes. And then the furthest right is, you're going to have to think about it, alright? The line, it will keep going on and on forever to the right, alright? It never stops. So where would be the furthest right? So to solve for the domain, the furthest left right here, you can't really believe the graph, right? The graph can be tricky because right here it could be 1/5, it could be 1/4, it could be 1/8. It's just not really a good idea to look at the graph and then trying to figure out the domain. So what you have to do is you have to calculate it. So to calculate this, you have to think about, this is the x-intercept. This is the x-intercept. So x-intercept means when the graph, when this line right here, it hits the x-axis. So that means y equals to 0. On the x-intercept, the y value right here is going to be 0. So how are you going to find it? You have to set y to 0. Alright, set y to 0 and then solve for x. Set y to 0 and then solve for x. So that is how you can find it. And then for y-intercept, set x to 0, find the y. Alright, this one right here, the highest point is going to be right here. The lowest point is, you have to pretend that it keeps going lower and lower and lower and lower, alright? It never stops. So highest point is right here, lowest point right here. And then the furthest left is right here. But this is open circle, alright? Open circle means not included. So be careful. When you're trying to figure out a domain, you got to be careful because it's open circle. So you're looking at some kind of a parenthesis. And then also another thing you got to be careful is there is a disconnection right here. There is a disconnection. So that means the graph goes from here and then to right here and then it stops. It stops. Whatever value is right here, this is not part of the function, alright? It is not included. So that means you are looking at something with a disconnection. You have two parts. You have the left part. You have the left part right here, and you have the right part. The left part goes from here to here, and then it stops. And then the right part, it picks up from right here and then it keeps going. So you are looking at two parts. And then also pay attention at the scale, because the scale is a little tricky. This is 4 right here, so that means this is a 2 right here. Yeah, the scale is always tricky. So if you didn't pay attention and you thought that this is a 1, then you will get it wrong, right? So the scale is a little off. So every one block is 2 units, all right? Every one block is 2 units. All right, let's keep going and see what else. Let me see. Determine whether each relation represents y as a function of x. So in order to be a function, 1x can only goes to 1y, all right? So every x can only have one y value. So you can do the vertical line test, all right? So the vertical line test tells you that at any given point, let's just say right here, all right? At any point on this line, you will draw a vertical line. You will draw a vertical line and make sure this line only goes through the graph once, all right? You can only cross the graph once. If it crosses once, then that means it is a function. And for this one right here, if it only cross once, you're good. If it cross twice, so let's just say I'll put a line right here. And this line, this vertical line, it goes through the line twice. So that means it failed the vertical line test. So in that case, not a function. It's just a relation, all right? It is just a relation, not a function. So you got to be careful. For every x value, you are only allowed to have one y value. And this one right here, let's just say this is a what, -6 or something like that. But then you have two y values up here and down here. So that means it fails. It's not going to work. All right, state the domain of each function. All right, state the domain of each function. So basically, this is just a really fancy way of asking you how far left and right does your graph goes. All right, this is just a really fancy way of saying how far left and how far right does the graph go. All right, so I hope that you are familiar with all the parent function. So all the parent functions, for example, linear is y equals to x, and then the graph looks something like this. And then quadratic, the graph looks something like that. And then cubic, the graph looks something like this. And then rational, the graph looks something like that. So this is something that you have to you got to make sure that you memorize all the parent function. So log x, and then the graph looks something like So you have to memorize all of those parent functions, and then when you do, it helps you a lot. So for example, when you just look at a problem, right away you can tell this graph is going to base off of the rational function right here. So it will look similar to this, but it will change a little bit, all right? It will look similar to this, but it will change a little bit. So if you're talking about domain, we are looking at how far left and how far right does it go. And for the rational function, you will see a disconnection right here. You will see a disconnection right here. This is the asymptote. Asymptote. I think I spelled it right. Because the line, it will keep going to the right, to the right, to the right, but then it will stop going to the right, but it will just keep going down, and then it will never touch the y-axis. And then the same goes right here. It will get really close to the y-axis, but it will never touch. All right. So the asymptote is something that the line will approach, but it never touch. So that means when you are doing your domain, you are expecting two parts. You are expecting at least two parts, sometimes more than that. You have one part that goes from negative infinity to 0 in this case, and then it will pick up from 0 and go back to infinity. For the parent function, all right, for the parent function, you are looking at something like this because of the disconnection. And then for this particular example, let's take a look at it. So very quickly, let's factor this. So I'm going to factor this into 4x plus 3, and then x plus 1, x plus 4, like this. And then nothing can cancel out, right? Nothing can cancel out. So in order to have a solution for a function, the denominator, all right, the denominator cannot be 0. All right, the denominator can never be 0, because if the denominator is 0, you are looking at undefined. If the denominator is 0, you are looking at undefined. So what you need to do is take the denominator, which is right here. Take the denominator, set it equal to 0. Set it equal to 0, and then solve for x. So since it cannot be 0, all right, the denominator, it can never be 0. It can never be 0. So now that you solve it, you will get two answers right here, -1 and -4. So that means your line will never have an x values of -1 and -4. So you don't really have to know exactly how your line looks like, but you will know that there will be a disconnection at -1 and -4. So when you do your domain and range, you know the line will base off of the rational function. So that means it will go as far left as -infinity. And then it will stop at -4. and then it will go from -4 again, and then it will stop at -1. And then it will go from -1 to infinity. Let's graph this. All right, let's graph this and take a look at it. 8x plus 12 divided by x squared plus 5x plus 4. X squared 5x plus 4. Alright, so this is how the graph looks like. Alright, this is how the graph looks like. So when you look at it, it will go as far left as -infinity, and then there will be an asymptote because the line, it will stop going to the right. It will just go in lower and lower and lower. So you have an asymptote right here. So this is -4. And then it picks up from -4, and then it will keep going right here to the right, but then it will stop. It will keep going lower again, and then it will stop right here. So it will approach -1, but it will never touch it. And then it goes from -1, pick up again, all the way to infinity. So we are looking at 3 parts. All right, there are 3 parts. The first part is this part right here. This is -infinity to -4. And then the second part in the middle right here, this is from -4 to -1. And then the last part is right here. So the last part is from -1 to infinity. Alright, so do the next one the same way. And then, to be honest, whenever you see a fraction, alright, whenever you see a fraction, it is going to be pretty similar, alright, pretty similar. Set the denominator to 0, and then see what values will make it undefined. Alright, for this one right here, you're gonna have to think about it. Is there any number of x that will make the y into undefined? Alright, is there any number right here you plug in? You will make the y into undefined. So in order to not have a solution undefined, the denominator has to be a 0. All right, up here you can have whatever number, doesn't matter. But down here, if the denominator is 0, that is when you not have a solution. That is when you have a disconnection. All right, for this particular problem, no matter what numbers that you put right here, the square will mix it into a positive number. So let's just put a random number, how about -6, something like that. When you put it in there, the square will mix this number into a positive. and then you will still get a answer. Square root of 37 is going to be 6 point something something, right? So you will always have a pretty good looking answers. Doesn't matter what number you put right here as x, you will get a pretty good looking number. So that means you are not going to have any undefined. All right, you will not have any undefined. So it's safe to say that your domain is going to go from negative infinity to positive infinity, because no matter what number you put right here, this function will never be undefined, and you are not going to have any disconnection like this. All right, you're not going to have an asymptote. Let's move on a little bit. All right, so right here, so if you look at this, you can possibly have an undefined right here if this is 0, or if this is 0. All right, so you cannot have equals 0. So solve for x, you will find your disconnection. So that means there are two different numbers right here that will make the function an undefined. So figure it out. And then the log function, use the log parent function. All right, the log parent function, it goes something like this. So the log function, you do have an asymptote. You do have an asymptote right here. So it goes as far left as the y-axis right here, but then it will keep going up and up and up, and then further and further right. And now look at the transformation. All right, look at the transformation. The plus 3, what does it do to the graph? Does it shift to the left or right, up or down, by how many units? This will change the domain as well. And then the same goes here. Check the transformation. All right, check the transformation right here. So the plus 2, think about what does it do to the graph. Does it shift left or right, up or down, by how many units? So the exponential graph right here, shifting it left and right really doesn't change the domain and range, because when you shift it left or right, you are still looking at a graph that keeps going to the right, and then it will keep going to the left right here. So it's not too much of a difference. All right, moving on. I think I talked too long. Sorry about that. All right, so for these relations and function, look at the furthest left and right. Okay, so for this one, use your imagination, extend the line. All right, extend the line. How far left does it go, and how far right does it go? And then also, how low does it go, and how high does it go? All right, so think about it. And then whenever you have like this connection like this, this is when it gets really fun. This is where the fun begins. So how far left does it go? The furthest left is right here. Open circle, so be careful. And then there are a whole lot of disconnection. You have a disconnection right here. You have a disconnection right here. So you got to be careful. You are looking at 3 parts, okay? You're looking at 3 parts. So you are probably going to have something that looks like this, all right? And then pay attention at the closed circle and open circle. And then this thing goes up like this. All right, so it will keep going to the right, and it will keep going higher and higher and higher. So don't let these multiple parts scare you. I mean, you're only looking at how far left and how far right does it go. And then the range, you got to be careful, because the highest point is obviously right here. You're looking at positive 8. But then you have to check if there's any disconnection. So for example, so you're going to scan through this. So I'm still good. I'm still good. I have numbers. And then close circle. So that means this is included. And then you pick up from right here. This is where it picks up. And then it's keep going down and down and down. And then at this point, this is a open circle. However, this part, you can definitely pick it up from right here. And then it keeps going down and down and down. So in other words, even though there is no value right here, you can make it up right here. So even though there's nothing right here, but then there is values right here. So you don't have to care about the disconnection right there. So the range, sometimes it can be tricky. Solve each questions algebraically for the x and the y-intercept. Alright, so this is super easy. X and y-intercept. So x-intercept means y equals to 0. And then y-intercept means x equals to 0. So basically, you for the x-intercept, you set y to 0. Solve for x. And then the other one, set x equals to 0. Solve for y. Let me see what else. I think this is it. Is that it? All right, this is it. Well, I hope that helps. If you have any questions, don't hesitate to ask. Right? I want you to ask me as often as possible, because I don't want you to fail your class. I want you to do good in your class. Okay? I mean, when I was in high school, pre-cal, I was the best. I really hope you can be the best in your school. But just do your best, okay? Do your best. Don't put too much pressure on yourself. Don't stress out. If you have any questions, let me know. I'll help you. I will definitely make sure I'll do my best. All right, so let's wrap it up right here. I think I talked too long, right? So some practice problems. If you have more questions, let me know.